Alright, welcome to Chapter 9, focusing on the binomial theorem. The first thing we need to explore is the concept of factorials. So, the first thing you need to know about factorials is they look like a letter or a number followed by an exclamation point. So, it looks like n factorial. The British sometimes say n shriek, right? Because exclamation points I guess, mean excitement, so they might say in shriek instead of n factorial. It means the same thing, colloquially, anyway. All right, so the big idea with factorials is it's a way to say that you want to find the product of all positive integers less than or equal to n. So just as a reminder, a positive integer does not include 0, okay, and the definition of an integer, that's positive. They're all positive whole numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, but again, it does not include 0. So if we're looking to find n factorial or n shriek, what basically happens is this number or letter in front of our factorial is our biggest value. Okay, so n could be 10, it could be 100, it could be 99, it could be anything, but it's the biggest number. And then every value that gets multiplied by it is 1 less than that value. So if this was 10, this would be 10 times 9 times 8 times 7, all the way until I get to 1. The way we write that mathematically is we say n times the quantity of n less 1 times the quantity of n less 2 times the quantity of n less 3, and so on. Now, the problem with using n as an example is that, well, we don't know what n is. It could be a Google, and that would be a really long expansion, or a really long series of numbers that are being multiplied together. So this is how you would write it. Most people would do something like this instead. So we know that 3 factorial is equal to 3 times quantity 3 minus 1 times quantity 3 minus 2. I'm stopping here because 3 minus 2 is 1. And remember, it's the product of all positive integers, which means we always stop at 1. So most people would say not this. They would say this. 3 times 2 times 1. So it's the product times every positive integer less than or equal to it. Okay? In that case, it's 6. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the smallest positive integer, so we stop. And that yields 5,040. 4 factorial, 4 times 3 times 2 times 1 equals 24. We're looking at this just as an introduction. It does have many more purposes than what we're going to talk about now. We'll actually get to that when we get to statistics. So let's actually look at how you calculate things using factorials. Okay, so the first thing I would say is beware. 7 factorial is a number that may or may not be, well, yes, it's a number that may or may not be divisible by 4. The problem is you may be tempted, not with this problem perhaps, because that would be kind of yucky to divide this, but maybe on this one you might be tempted to say, well, this reduces down to 5 fourths, so that's so much easier because 5 factorial divided by 4 factorial. Don't do it. It doesn't work that way because these aren't numbers. These represent a product of numbers. So you can't simplify division, or for that matter, you can't multiply factorials together when the exclamation point is present. You actually have to expand them out. So let's go ahead and do that. So we know 7 factorial. 7 is the largest number, and we lose 1 every single time. Remember, we're finding the product, which means we're multiplying. And we stop when we hit the smallest positive integer, 1. Alright, now we're going to do the same thing with 4. But watch where I'm writing this, and maybe as I'm doing this, you can think about why. Any idea why I set the 4 under the 4, and the 3 under the 3, 2 under the 2, 1 under the 1? These are all multiplied, right? Which means that the 4 divided by the 4 makes 1. The 3 divided by the 3 makes 1. 2 divided by 2 makes 1. And 1 divided by 1 makes 1. So it cancels out. So really our our product ends up being 7 times 6 times 5, which is 210. All right, so here's the key to this idea. So basically, our top number, right, we start with. The bottom number tells you what number in division is going to be canceled out first. In this case, 4, and everything below it will be canceled out, right? So what that means is I can stop when I get to an integer, the first integer greater than 4, which in that case is 5. So I just need to say 7 times 6 times 5. Okay, let's try it with this one, the shortcut method. So I'm going to start 10 times 9 times 8, but I'm going to stop here. And I know this would go all the way to 1. Times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? This one, this is always our biggest number, right? So I'm going to start with 8. But now I have 8 divided by 8. This would keep going until 1. This always gets divided off, right? That was really ineffective writing in white pen. So this becomes 1. Everything here becomes 1, and this becomes 1. So the only two numbers I end up multiplying are 10 and 9, and that gives me 90. If I wanted to do this shorthand, I would say, well, of course it's 90. 10 times 9, and I stop at 9 because 9 is an integer greater than 8. Okay, done. All right, so what happens if you have n in your factorial? As part of your factorial. So you're not going to get a numerical answer, you're going to get an answer that's a product of terms including n. So basically our biggest, that was a really crooked line, let me try that again. Our biggest value, still not very straight, is n plus 3, right? And then what happens here? We lose 1. So n plus 3 minus 1 gives me n plus 2. N plus 2 minus 1 is n plus 1. Take away 1 from this, we get n, so you see I'm deducting 1 less. I'm going to stop here, although this would go on forever, right? Because it's n, and I don't know what the value of n is. Why I stopped at n minus 1 is because look what I have in the denominator. My first term is n minus 1, which means that this isn't going to appear in my final simplified answer. N minus 1 times quantity n minus 1 is 1. So my final answer is long. It's quantity n plus 3 times quantity n plus 2 times quantity n plus 1 times n. Or, if you really like writing from, this would be biggest to smallest, or greatest to least, you could write from least to greatest, it doesn't really matter. All up to you, in this case, how you want to do it. Okay? Alright, so that's your final answer there. So we're not looking for a single number, we're looking for a product of binomials, or just a product of variables. So, alright, we're going to work in reverse now. So, we are going to write each of these in terms of factorial. That means with a factorial in it. So, look for your biggest number. In this case, it's obviously 10. That goes in our numerator. Our smallest number is 7. That's 1 more than the first term that gets canceled out, which would be here. That would be times 6. That means 6 has to go in the denominator, because there would also be 6 down here. It's the first one to get canceled out of many. Okay, so that's our answer here. This one, our largest term, if you get stuck on figuring out which one's the largest, you could always plug a number like 10 in, and that would help, and that would clearly identify that 10 minus 1 is the largest term, and 10 minus 3 is the smallest. So our numerator starts out with n minus 1 factorial. Okay, this guy stays, but the next term would be 1 less, right? And that one goes, right? That's the first one to go, and I should be better about putting these go on forever. So the one that goes first goes in the denominator, because it doesn't exist in our final answer. Okay. And now for one that's slightly more tricky, and it's only tricky because it's written in a different order. So we always want to start with our largest number. This is our smallest. This is our largest. Okay, again, if you're stuck, plug 10 in and see which one's the biggest. Right at 11, is the biggest term in our product, or the big, yeah. And what would come next? Well, that would be n plus 1, right? That means that it's going to get divided off, as is every value subsequently, occurring after n plus 1. So in the denominator, we have to put n plus 1. I should also mention, and I didn't do this deliberately yet, anytime you have subtraction or addition in a factorial, you must use parentheses. If you don't, it doesn't mean the same thing. So since there's addition here, I have the factorial applies to the whole parenthesis. Okay, same here. So just general rules of math in terms of parentheses. All right, let's jump back to the PowerPoint here. Okay, so just a reminder, common errors that people try to make their lives a little easier that don't work with factorials, that'd be dividing the numbers. Remember, this is a product of numbers. So 8 factorial divided by 4 factorial is definitely not 2 factorial, and you can work that out to see why. And 3 factorial times 2 factorial cannot be combined to make 6 factorial. Okay? Also, definitely not even close to the right answer. Alright, this is going to be posted on Haiku, so if you guys want to have a look at this down the road to see how this works, you could totally do that. And one thing, I don't want you to use this on your what you're going to be doing in class, but for those huge factorials, and I say huge, that I don't mean huge, because your calculator can only show so many digits, so you might not see everything. But for the large ones that you don't want to do by hand, there is a factorial button. So, like, if I were trying to find 12 factorial, you would type 12, and then shift, oops, shouldn't have hit the keyboard, sorry, shift, and then x to the -1, and that would get you your factorial, your exclamation point. Alright, so for the next 10 to 15 minutes, you are going to work in groups on page 119, numbers 3 through 5. Make sure that you're checking your answers in the back so that you know that you're doing this right.